In this video I'm going to explain a method of proof called proof by contrapositive, and it's really a direct proof method, but we just need to do a little bit of work before we actually do the direct proof. So to understand proof by contrapositive, we need to understand what the negation of a statement means. So the negation of a statement is its opposite or its complement, and probably in everyday use opposite is a pretty good way of understanding something, though maybe mathematically complement, the complementary event, might be a bit better. So just as an example, we might say the opposite of coming first is coming last, whereas the complement of coming first is not coming first. So it includes all the other possibilities. So we'll think about some specific examples. The negation of P we can just write or state as not P, or one of the symbols that we can use, the notations that we can use, is P dash in that form, and we're familiar with that from P complement. So let's think about a couple of statements and try and come up with their negation. So I've got examples here of P, and then I'm going to write in the not P statement. So if P was the statement, the proposition that X is odd, then not P we could say is X is not odd. So I'll write that first of all, even though X is not odd. We could say that, although probably we would more naturally say X is even. So X is even. That one's hopefully fairly straightforward. The next one I've put in because I think this does highlight the fact that we need to be a little bit careful. So if we wanted to say what is the negation of 5 is greater than 2, we could just say 5 is not greater than 2, and we could write that like that there. But again, we'd probably more naturally express it a different way. And here we need to be careful, because if we said what's the opposite of 5 is greater than 2, we might say, well, that's 5 is less than 2. But in fact, 5 being not greater than 2, we would say 5 is less than or equal to 2. Alright, so we just need to be a little bit careful, because the complement or the negation of greater than is not just less than, but less than or equal to. And likewise, the negation of, if the statement was 5 is greater than or equal to, then its negation would be 5 is less than 2. So whichever side sort of has the equals in, the other side of the statement won't have it. Now what about this one? All odd numbers are prime. We could maybe say not all odd numbers are prime. Now you might think, well, it's more natural to say all odd numbers are not prime, but in fact that's not the negation of that statement. So if we say all odd numbers are not prime, we mean every single odd number is not prime, whereas the negation of all odd numbers are prime is really just that there's at least one odd number which is not prime. So here we could say, another way of saying it would be at least one odd number, not off number, odd number. Odd number is not prime. So that's an important example there at the end, because the negation of an all statement is not another all statement, it's just at least one. So let me just say that again. To say that all odd numbers are prime, the negation of that is saying there's at least one odd number which is not prime. It's not saying that every odd number is not prime. Okay, so that's the idea of a negation. So how do we use proof by contrapositive? Well, basically proof by contrapositive, so the contrapositive of a conditional statement requires negating both parts and reversing the implication. So how does that look so i.e. the contrapositive of P implies Q is, well, we've got to take the negation of both, so that would be not Q and not P, excuse me, and we have to reverse the order. So instead of the order going from P to Q, it's now going from not Q to not P. So our original statement was if P then Q, or P implies Q. The contrapositive of that is if not Q then not P. And the significant thing here is that a statement and its contrapositive are considered equivalent. So in other words, if we can prove the contrapositive, then we've proved the original. So a statement and its contrapositive are logically equivalent. So let's do an example here of why we might use the contrapositive. And basically it comes down to the fact that it might be easier to prove the contrapositive than the original statement. So for example, let's prove that if 5n plus 3 is odd, then n is even. Right, so if we're going to prove that as it stands, then we'd be letting 5n plus 3 be equal to an odd number, or expressing it as an odd number, and then we'd be trying to do some algebra to show that n always turns out to be even. But that's going to be a bit awkward. Whereas, if we go the contrapositive, well, let's actually write the original first. So the original statement is 5n plus 3 is odd, implies n is even. So the contrapositive would be, well, let's take the second part and negate it first. So n is not even, or in other words, n is odd, implies, and take the 5n plus 3 and negate it. 5n plus 3 is odd, its negation would be 5n plus 3 is even. Now that's a much easier thing to prove, that if n is odd, then 5n plus 3 is even. So let's prove that. So let's go n, let n be equal to 2k plus 1, where k is any integer. Therefore 2k plus 1 would always be odd. Therefore 5n plus 3 is equal to 5 lots of 2k plus 1 plus 3. So what's that? 10k plus 5 plus 3 is 8. And let's write that in the form of an even integer, which is 2 lots of some integer, so 2 lots of 5k plus 4, which is always even. Since the contrapositive is true, then the original statement is true, or implication is true. Alright, so that's how proof by contrapositive works.